Hi everyone. My name is Rachel Margareta Dongaran from Geological Engineering, and today I'll be presenting about sedimentary structures. So, I'm going to be talking about how they form, what they tell us about the past, and why they're so important in understanding our planet's history. This topic is actually one of the key foundations in sedimentology and stratigraphy because sedimentary structures record the processes that shape sediments before, during, and after deposition. So, by studying these features, we're basically reading Earth's diary. So in here we're going to unlock sedimentary structures. So, sedimentary structures are physical features that show how particles are arranged inside layers. They're formed by physical, chemical, or biological processes, and they can reveal so much about the conditions under which the sediments were originally deposited. For example, the patterns, layering, and marks we see in rocks are actually clues about ancient rivers, oceans, winds, and even the presence of life million years ago. So, through these structures, we can reconstruct past environments, like knowing whether a rock was formed in a calm deep sea, a fast flowing river, or a desert dune. Okay, so understanding rock types and the forces shaping them. Now, before we talk about structures, let's go through the main types of sedimentary rocks because structures appear across all of them. So first we have detrital or siliclastic rocks like conglomerate, sandstones, and mudstone. These are formed from broken pieces of older rocks. They're mainly shaped by physical processes such as flowing water, wind, or sediment supply. Carbonate rocks like limestone and dolostone, these form mostly from chemical and biological activity, such as the accumulation of shells or precipitation of minerals in marine environments. And other types include evaporites, phosphate rocks, organic rich rocks, chert, and even volcaniclastic deposits. All these rock types can display sedimentary structures, meaning structures aren't limited to one setting but occur in almost every sedimentary environment on Earth. Okay, so now why are sedimentary structures important? Because they give us clues about how and where sediments were deposited. So they help us to determine the direction of flow, estimate the depth and energy of the water, identify which side of the rock layer was originally the top or bottom, and reconstruct ancient landscapes and past environments, such as river channels, deltas, or coastal zones. And in other words, by looking closely at the shape and arrangement of these layers, we can decode the history of an environment that existed long before us. Okay, moving on. Hold on. Okay, so in here, erosional sedimentary structures, how flow shapes sediments. The first group we'll talk about is erosional sedimentary structures. These form when flowing fluids, like water or wind, carve into the surface of soft sediments before new layers are deposited above. In simple terms, the flow erodes or scours the surface. Then later, the new material fills in those erosional features. So, common examples include soul marks, flute casts, groove casts, channels, and scours. Each of these features records the movement of a current and help us understand the direction and energy of ancient flows. So here we're recognizing key erosional structures. So let's go through some of the most common examples. First we have groove cast. These are long, narrow, trench-like marks formed by the erosion of the surface by tools or debris carried by the current. Later, these grooves get filled by sand and become preserved as ridges on the underside of the overlying layer. Okay, next we have flute cast. These look like spoon-shaped depressions, which with one end wider and deeper, often resembling a flickering flame shape. So here we can see in the flute cast. They form when eddies in turbulent currents scour out small hollows in the mud, which are then filled by sand. Channels and scours is next. So Here's the picture. And then these are larger erosional features, sometimes extending for meters or even kilometers. They're basically small valleys carved by strong currents, which later on will be filled by newer sediment. So, all of these erosional structures tell us about how flow direction and energy, and they often appear on the base of sandstone layers, resting above finer grained rocks like mudstone or shale. Okay, so this is a more detailed information on how soul marks form. So, on the previous slide, soul marks are basically groove cast and flute cast. So this is how they form. The formation process of soul marks can be summarized like this. Initially, a mud layer is deposited, then currents erode the surface, creating small depressions or grooves. Later on, coarser sediment like sand settles into these depressions. When the whole layer hardens, the base of the sand layer preserves the positive cast of those features. That's what we see as the soul mark today. And so that is how soul marks form. Okay, moving on. Now, this is how sediments shape layers and patterns. So, we have the positional structures, which is formed as sediment particles settle and accumulate. Some of the key types are first, we have bedding. So they are thicker layers, more than centimeters thick. And then we have lamination, which is almost similar as bedding, but they're very thin layers, and then they're less than 1 centimeters thick, which shows finer details. Next, we have graded bedding. So this is where the grain size changes gradually from coarse at the bottom to fine at the top. So we see a difference in size in graded bedding. And then we have ripple marks and dunes, which are patterns formed by water or wind movement across sediment surfaces. And they're actually much more easy to identify. So these structures tell us about the energy, flow conditions, and sediment supply during deposition. Okay. Next we have, okay, let's talk more about two very common depositional structures, which is cross bedding and ripples. So cross bedding happens when inclined layers formed as dunes or ripples migrate over time. So there are two main types: planar cross bedding or flat layers, and through cross bedding, which is curved layers. So these are important because they show the direction of flow and help us interpret ancient current systems. Ripples are small wave-like patterns seen on the surface of sediment layers. Asymmetrical ripples indicate a one-way current, like a river flow, while symmetrical ripples formed from oscillating wave motion, such as in shallow marine environments. We can also find lenticular wavy inflazer bedding, which show alternating layers of sand and mud. So these structures usually form in environments where the current conditions change, for example, in tidal flats where water movement varies between calm and energetic. Okay. So how sediments change after settling? Once sediments are deposited, they can still change before they turn into solid rock. So these are called post-depositional structures or soft sediment deformation structures. So some examples include we have load cast, which is bulbous downward features formed when a heavier sandy layer presses into a softer muddy layer below. Okay, next we have slides and slumps. So these happen when sediment layers move downslope before they harden, often forming curved or folded patterns. Next we have mud cracks. These appear when muddy sediments dry out and contract, leaving polygonal cracks. Then we have dish and pillar structures, which are caused by water escaping upward from rapidly deposited layers, leaving behind bowl-shaped or column-like patterns. And these features give us insights into deformation processes, waterscape, and environmental changes after deposition. I mean sedimentation. Okay, next, the last group is biogenic structures, which are features made by the activity of living organisms. These include tracks, trails, and burrows made by animals moving or digging through soft sediment. Together, they're known as trace fossils, and they help us interpret not just the environment but also the behavior of ancient life. For example, tracks are footprints or impressions left by the movement. Trails are linear marks formed by organisms dragging or crawling across the surface. Burrows are tunnels dug into sediment for shelter or feeding. We can also find stromatolites, which are layered structures formed by cyanobacteria. They're one of the oldest signs of life on Earth, dating back to the Precambrian, and they still form today in shallow marine environments. Through these biogenic features, we can connect the physical world of sedimentation with the biological world of ancient ecosystem. Okay. So to wrap it all up, sedimentary structures are like the pages of a history book right in stone. They form through physical, chemical, and biological processes before, during, and after the sedimentation. By studying them, we can uncover how ancient environments looked, how currents flowed, and even how life interacted with the sediments around it. So, in short, by unlocking these structures, we unlock Earth's history story. So, thank you so much for listening and thank you for your attention.